we are Team TapOut. Today we will be presenting our group project, the heart rate monitor. So here's our circuit implementation. As you can see, initially we have a user interface implemented where for when you press A, you're going to measure heart rate, B to measure heart rate variability, C to measure glucose level, and D to measure temperature. So first we will show heart rate.
Show Daisy rate manual.
Yeah, this is the Alright, so A. Wait, hold on. A. So this would measure the beats per minute for 10 seconds and then multiply it by 6 to get it for a minute. Alright, and as you can see, his heart rate is 78 BPM, which is within the range. So we'll now do it over without applying the IR LED to see if the speaker will sound when it's outside the range of 40 to 140. Well, would you look at that? Right. So press E to go back to the main menu. So next is heart rate variability.
That's seen again.
Again, we have test subject Daniel. So press B. And we wait again for 10 seconds. Where it's measuring the timing in between pulses, and any that is above the 50 milliseconds threshold will be accumulated and then put over the total number.
Right.
And expressed as a percentage.
Okay, let's take it.
Right, so as you can see, HRP is 30%. So go back to the main menu. So glucose level. For glucose level, we implemented a circuit, but we didn't get around to writing the actual code for it. So to just show that it could be displayed, we entered some dummy values into an array to be displayed. So as you can see, the first one is 70 mg per dl. And go back to the main menu. We have temperature. So when you press D, it will show the current temperature. And here we have the DS1822. And you can see when I put my hand on the temperature sensor, the temperature will be increasing. So it's changing. So go back to the main menu here. So in one of the objectives was to display all the measurements to the LCD together. So when you press F, it will go to a screen which displayed the last set of readings for each. Right. Oh, with respect to the flash RAM, we didn't quite get around to doing the circuit and implementing the code for it. But in the interest, like, if we had more time, you know, we would have done it. And the power, the brownout. So for that we used a comparator and a transistor to switch in between. So we had the external battery, which just used the next side of the power supply, and we connected that and the voltage from the PIC. So the comparator would then compare the two voltages, and if the voltage from the PIC circuit goes below, it's about 4.5, it would switch over to the external battery. But we didn't really have the code running up for that. You want to try to run it?
Programming.
Hold on, I was given some problems before, so we'll see.
I don't think it pulled it out.
Okay, let me pull out this. Pull out the power supply there.
Cut off.
And it cuts off, but the circuit's still getting powered. I don't think it's enough to drive the PIC though, the transistor to switch over. So yeah, that was a problem we encountered there. So what else do you have to present on? Yeah. I don't know if y'all want to add anything that I
Oh, we kind of like attempt the flash memory with the circuit, but we was getting some problems with the shift registers. We're not sure if it's like a timing issue or something, but that was yeah, that was the problem we was getting with the flash memory.
And with respect to calibration, well, we use SLs to check to see if the values we got were close to the actual ones as measured on the phone, and they were pretty close. I think it was around plus or minus 4.
Yeah. Temperature we use. Oh yeah, for temperature, we had a multimeter with a temperature probe on it, and we tested and it was more or less accurate according to the multimeter.
According to the
Okay.
Yeah. So are there any questions from my classmates? Any questions? No?
Any questions?
Well, I'd like to thank you all for your time. This was nice.